Technology gap models of international trade explain trade patterns based on differences in technology and the time lag it takes for technology to diffuse across countries. These models challenge the traditional Heckscher-Ohlin (HO) model, which assumes all countries have access to the same technology. 1. Posner's Technology Gap Model, 1961. The original and foundational technology gap model was developed by Michael V. Posner in 1961. It argues that trade arises not just from static differences in factor endowments like labor and capital, but from the continuous process of innovation and imitation in the global economy. Core mechanism: 1. Innovation and temporary monopoly. A technologically advanced country, typically a developed nation, innovates a new product or a superior production process. This gives the innovating country a temporary monopoly and an absolute or comparative advantage in that product. 2. Exports to the world. The innovating country exports the new product, establishing a trade pattern that is not determined by traditional factor costs. 3. Imitation and erosion of advantage. Over time, firms in other countries, particularly those with similar demand characteristics or lower labor costs, imitate the new product or technology. Once imitation occurs, the innovator's advantage erodes and the trade pattern shifts. The technological gap. The technology gap is the time lag between the appearance of a new product in the innovating country and the introduction of a successful substitute or imitation by a foreign producer. Posner breaks this lag down into three key components. Lag component. Description. Effect on trade. Imitation lag. Foreign reaction lag. The time required for the first foreign firm to learn and adopt the new technology to produce a substitute. The longer the imitation lag, the longer the innovator enjoys its monopoly, and the larger the trade volume. Demand lag. The time required for consumers in the foreign country to become aware of the new product and develop a demand for it. The shorter the demand lag, the earlier the foreign country starts importing the product. Net effect. Trade occurs only if the demand lag is shorter than the imitation lag. If the foreign producers can imitate the product before their domestic consumers start demanding it, i.e., imitation lag less than demand lag, there will be no imports and thus no technology gap trade. 2. Vernon's Product Life Cycle (PLC) Model Extension. The technology gap model was further developed and formalized by Raymond Vernon in 1966 with his Product Life Cycle (PLC) model. The PLC model retains the core idea of a technology gap but adds a time dimension to production and location decisions. Vernon suggests that comparative advantage for a product shifts over its life cycle as the technology matures and becomes standardized. Stage. Innovating country advantage. Production location. Trade pattern. 1. New product. Technology intensive. R&D, skilled labor, uncertainty. Home country. Innovator. Innovator country exports to a few high-income countries. 2. Maturing product. Scale intensive. Standardization begins, mass production. Home country plus production may begin in other developed countries. Innovators' exports peak, and it may start losing market share to imitators. 3. Standardized product. Cost intensive. Process is stable. Unskilled labor is key. Developing countries, low-cost labor. Innovating country becomes an importer of the product from developing countries. PLC as technology gap dynamics. The shift from stage 1 to stage 3 represents the closing of the technology gap. The initial temporary advantage based on new knowledge eventually moves to a comparative advantage based on traditional factor costs like cheap labor, as the technology is fully absorbed globally. Significance of the technology gap models. Explaining intra-industry trade. The model successfully explained the trade patterns of the post-World War II era, particularly the trade of manufactured goods between developed countries that were supposedly similar in factor endowments. This was a key weakness of the HO model. Dynamic advantage. They introduced the concept of a dynamic comparative advantage based on innovation, challenging the static nature of older trade theories. Role of government policy. The models implicitly underscore the importance of investment in R&D and education for a country to maintain its trade competitiveness by continuously creating new technological gaps. Technology as a trade determinant. They established technology and the non-public good nature of initial knowledge as a fundamental and primary determinant of international trade.